In section 1.3, we will talk about operations with fractions. What's the meaning of a fraction? A fraction can be used to describe a part of a whole. For example, if you want to take 3/4 of a pizza, we first have to take a whole pizza, and the denominator is 4, which means we would divide the pizza into 4 equal parts. Since we want 3/4 of the pizza, we will take 3 of the 4 parts. Now let's say, on a side note here, we wanted to eat 3/8 of a pizza. In that case, dividing the pizza into 4 equal slices will not be helpful because our denominator is 8, which means we need to divide the pizza into 8 slices. So we have 1, 2, 3, 4. If we do this, we now have 1, 2, 3, 4, 5, 6, 7, 8 equal slices. And if you want to eat 3/8 of the pizza with 8 equal slices, that means we would be eating these 3 slices. Now notice 3/8 is much smaller than 3/4. 3/4, it means we're eating 3 slices out of 4. 3/8 means we're eating 3 slices but out of 8. So 3/8 is smaller than 3/4. Fraction a over b means a divided by b. For example, if we see 18 over 2, this is equivalent to saying 18 divided by 2, which is 9. Another way to simplify this, we find a number that can divide both the numerator and denominator. Since 2 can divide the numerator and 2 can divide the denominator, 18 divided by 2 is 9, 2 divided by 2 is 1, and 9 divided by 1 is 9, which will give us the exact same result. The fraction a over b is undefined if b is equal to 0. Division by 0 is undefined, so if you have 5 over 0, or 6 over 0, or negative 10 over 0, or really any number over 0, then these are all undefined. Any number times 1 is that number itself. Any number divided by 1 is the number itself. Now if a is non-zero, because remember we cannot divide by 0, then a divided by a is equal to 1. Now in multiplication, if we have a fraction a over b times a fraction c over d, we simply multiply the numerators and multiply the denominators. So a over b times c over d is equivalent to a times c over b times d. Notice that in multiplication, we do not need a common denominator. We can simply multiply the denominators. Here's an example. Let's find the product of 2/5 times 3 over 7. Well, according to our rule, we would multiply 2 times 3 and multiply 5 times 7. Note that the denominators being different, it doesn't matter in multiplication. 2 times 3 is 6, and 5 times 7 is 35. We must always try to reduce our fraction. So when you reduce a fraction, we think to ourselves, can any number divide both 6 and 35? No number can divide 6 and 35 at the same time, so this fraction is in the simplest or reduced form. We will talk briefly about writing a number as product of primes, though we will not be using it much in this section. So when you write a number as a product of primes, you write the 54 into as any two numbers, product of any two numbers. Let's use 6 and 9. We could have also used 18 and 3, or 2 and 27. Neither of these are prime numbers, so we write 6 into a product of two more numbers, 2 and 3. Now 2 and 3 are both prime numbers, which means they can only be divided by 1 and that number itself. 9 is 3 times 3. Once again, 3 is also a prime number. So the prime factorization of 54 is 2 times 3 times 3 times 3. Let's simplify 30 over 42. So when you simplify a fraction, you think about what's the biggest number that can divide both 30 and 42. So offhand, I know that 6 can divide 30 and 6 can divide 42. 30 divided by 6 is 5, 42 divided by 6 is 7, so my answer is 5 over 7. Now let's say I couldn't think of 6 as being able to divide 30 and 42, I could do this a little bit in a little bit more long-winded way as well. So if I look at 30 and 42, think of the smallest number that can divide 30 and 42, which is 2. 30 divided by 2 is 15. 42 divided by 2 is 21. Now, what can divide 15 and 21? Well, we know 2 can't. What about 3? Yeah, 3 can divide 15, 3 can divide 21. 15 divided by 3 is 5, 21 divided by 3 is 7, so our answer is 5/7. A lot of the scientific calculators can also reduce fractions, so you can always use your calculator to reduce fractions as well. Let's find the product of 8/9 times 15/4. It's easiest to cross-cancel and reduce fractions before multiplication, but I'll do it both ways. Let's first do the long way. The long way is where we don't cross-cancel, where we just multiply 8 times 15 and we multiply 9 times 4. Well, 8 times 15, that's 120. 9 times 4, that's 36. Now we got to find which number can divide both 120 and 36 at the same time. Well, I know 12 can divide 120 and 12 can divide 36. So 120 divided by 12 is 10. 36 divided by 12 is 3. If you couldn't, if you didn't know that 12 divides 36 and 120, you could use smaller numbers such as 2s and 3s. It'll take a little bit longer, but you will get to the same answer. But this way is inefficient because you have a large answer to simplify at the end. Let's look at a different way of doing this. We have 8/9 times 15/4. We can cross cancel. In other words, we can think to ourselves, 8 and 4, do they have anything in common, or can they be divided by the same number? Yeah, well, 4 can divide 4, 4 can divide 8. So 4 divides 4 and 4 divides 8. Same thing with 9 and 15. 3 can divide 9 and 3 can divide 15. So let's look at our result. 8 divided by 4 is 2. 9 divided by 3 is 3. 15 divided by 3 is 5. 4 divided by 4 is 1. Now we cross multiply. 2 times 5 is 10. 3 times 1 is 3. So once again, our answer is 10/3. A common way of writing this, and I showed you guys here what was going on. Usually we do this. 4 goes into 4 once because 4 divided by 4 is 1. 4 goes into 8 twice because 8 divided by 4 is 2. 3 goes into 9 3 times. 9 divided by 3 is 3. 3 divided by 15 is 5. Again, 2 times 5 is 10. 3 times 1 is 3. I showed you 3 different ways of simplifying fractions, and you can pick your favorite way. Let's talk about the reciprocal. The reciprocal of a over b is b over a. For example, the reciprocal of 3/8 is 8/3. Let's take a number like 6. If a number is an integer does not have a denominator, we can always write that as 6/1. So the reciprocal of 6/1 would just be 1/6. Now let's talk about dividing fractions. If b, c, and d are non-zero, then a over b divided by c over d equals to a over b times d over c. In other words, dividing by a fraction is equivalent to multiplying by the reciprocal of the fraction. For example, 3/4 times 1/8 is equal to 3/4. We can't divide by a fraction, so instead we multiply by the reciprocal, which is 8/1. I'm going to cross cancel. 4 goes into 4 once, 4 goes into 8 twice. 3 times 2 is 6, 1 times 1 is 1, and 6 divided by 6, or 6 divided by 1 equals to 6, which is our answer. Let's talk about adding and subtracting fractions. If you have a over b plus c over b, where you have a common denominator, we can simply add the numerators, but the denominator does not change. So there's one big difference between multiplication and addition. In multiplication, we can always multiply the denominators, whether they're like denominators or not. For example, we multiply 3 and 1. However, in addition and subtraction, we can only add and subtract fractions with a common denominator, and the denominator does not change. For example, 4/15 plus 6/15, because we have a common denominator, we keep the common denominator, and on the numerator, we would write 4 plus 6. which will give us 10 over 15. We can reduce this. Think of the biggest number that can divide 10 and 15, which is 5. So 10 divided by 5 is 2, 15 divided by 5 is 3, which means our answer is 2/3. But notice, we needed to have a common denominator, and when you add the numerators, the denominator does not change. Now let's talk about the least common denominator. The least common denominator of a group of fractions is the LCM of the denominators of all the fractions. Now don't worry about that. A least common denominator is a number that all the denominators can go into. For example, let's say we have 1/4 plus 1/6 plus 3 over 8. The least common denominator is a number that 4, 6, and 8 can all go into. For example, let's take a number like 12. 4 can go into 12, 6 can go into 12, but 8 cannot. That is not the LCD. So let's try 24. 4 can go into 24, 6 can go into 24, and 8 can go into 24. That is the LCD. Okay, let's find the sum of 5 over 8 plus 5 over 6. Well, because we don't have a common denominator, our first step is we have to find what is the LCD. Sometimes you can find the LCD just by looking at these. So which number can 8 and 6 both go into? There's a question we want to ask ourselves. If not, we list all the multiples of 8 and all the multiples of 6 until we find a number that's common to both. Because we know that these are numbers that 8 can go into. These are numbers that 6 can go into. You want to find the least common denominator, which means the lowest number that both 8 and 6 can go into, which in this case is 24. So our LCD is 24. Which means if we add our fraction, 5 over 8 plus 5 over 6, we want to rewrite each fraction using a denominator of 24. To rewrite 5 over 8 using a denominator of 24, we would multiply by 3. So 8 times 3 is 24, 5 times 3 is 15. Same with the 6. 6 times 4 is 24. Whatever you do to the denominator, you must do to the numerator. So this will give you 20 over 24. Once we have a common denominator, you write that over one fraction. This gives us 35 over 24. Let's try to reduce this. Can we find a number that 35 and 24 can both go into? In this case, we cannot, so this is the final answer. The same principle applies for subtraction. If you have a common denominator, we simply subtract the numerators. For example, if we have 5 over 8 minus 3 over 8, this equals to 5 minus 3 over 8, which is 2 over 8. To reduce the fraction, we can divide both numerator and denominator by 2, and this will give us 1/4. Once again, same denominator, we can add or subtract the numerators. What happens if we don't have a same denominator? We got to first find out what is the LCD. Well, between our denominators are 9 and 5, between 9 and 5, if we list all the multiples of 9, all the multiples of 5, the least common denominator is going to be 45. That's the first number they both have in common that they can both go into. So since the LCD is 45, let's rewrite 8 over 9 and 3 over 5 using a denominator of 45. So 9 times 5 is 45, which means 8 times 5 is 40. 5 times 9 is 45, which means 3 times 9 is 27. Once we have a common denominator, we can write 40 minus 27 on the numerator. 40 minus 27 is 13. Our answer is 13 over 45. This cannot be reduced, so this is our final answer. Okay, think of questions. I'll be happy to go over those in class.